All right, your next video on matter would have to relate to separating it. So the first video, which I highly recommend you watch if you have not yet, is on classifying matter into these 4 types, okay? If you know the matter you're talking about, then you know how to separate it, all right? So if you didn't look at the video, again, please look at it because this will make a lot more sense. But going into how you're going to actually separate this. So if I give you something in a lab, you have to figure out how to separate them from each other. Well, you got to know what you're talking about, okay? So these 2 guys right here, if you remember, elements and compounds, are called pure substances. So pure substances mean that they're only made of elements, and the elements are either separate and they're just elements, or they're bonded together. There isn't anything else other than that. So elements are called the building blocks of matter. Building blocks. I'm going to put that down. So that means, literally, that this is as simple as it gets. So you can't break down elements into anything simpler. So on the periodic table, that's it. That's what everything's made of on Earth, all these elements. So you can't go any simpler. So you cannot separate elements, okay? Cannot. So make sure you understand the X means you cannot separate them. But when you're talking about compounds, compounds are when at least one or at least 2 elements are bonded together. So I'm going to put the word bond. Okay, they're bonded. So that means you can unbond them. So unbonding them takes a lot of energy. Okay, so to separate them, it takes a lot of energy. I'll just put energy for that. So that means energy. So if you want to unbond something, let's just take water for example. So here's your example, okay? You got H2O. And I want to separate that into hydrogen gas and oxygen gas. We'll talk why there's a 2 there. Don't worry about that later, or right now. We'll talk about that in future units. But basically, you have hydrogen gas and oxygen gas, and you want to break that bond. So how do you do that? So you have to add a lot of energy. In what form? Electricity. Okay? So one way of doing this is electrolysis. All right? So one method is shooting electricity into the water so much that it will break the bond that the elements are made of. So if you want, or the compound it's made of. So if you've ever heard of hydrolysis, hydro water, sys means to split. So you're splitting water. Well, they use electricity to do that. So if you want hydrogen gas and oxygen gas, you'll be able to get that. You'll be able to get that through shooting electricity through water. NASA does that for hydrogen and oxygen gas when they're up in the moon, the Mars trip, all that kind of stuff. If you watch the movie with Matt Damon and going up to Mars, you'll maybe remember what they were talking about with that. So anyways, that's one method, electrolysis, okay? The other method is thinking about how you could do this without adding a lot of energy. You're just adding some other compound to it. So this is more of a chemical reaction. So you're going to add something. So the other way is adding something. So an example, let's just say I want to get hydrogen gas out of water. Well, if you add potassium, for example, potassium is K, and you add it to water, you're going to get your hydrogen gas. So I put a plus to the H2s down here to save room so you guys can see that. But hydrogen gas you can get by adding potassium. So if you throw potassium metal in water and you put in a closed container, you will get hydrogen gas. So this is called a chemical reaction. RXN means reaction. So those are the only 2 ways of separating compounds. You can tell that it takes a lot of energy, or you need to add something that will cause a reaction. Not everything adds, you add some water, you know that adding water doesn't necessarily mean a reaction will occur, okay? Going into here, we're talking about mixtures now. 3 and 4 are called mixtures, if you remember that. Easier, much easier. So I'm going to put easy. We have to deal with physical properties, okay? So I'm going to put physical here. So physical properties means I can separate them through density, through their boiling points. So I'm looking at their physical properties, basically. Their solubility, all that kind of stuff are physical properties that allows me to take them, separate them. So let's just do the famous saltwater. You're stranded in an ocean and an island surrounded by saltwater. How do you do that? And a lot of you already know, but you got to know why, right? So let's use an example here. So homogeneous would be like a solution, okay? Talking about a solution. And let's just do an example of salt water. Salt, water. And I'm going to put what it actually looks like on a periodic table. So you got salt, NaCl, and water. That plus does not mean they're bonded. They're just mixed together. We'll talk about why things mix and why things don't mix later on. But the idea is this is bonded together. That is bonded together. So salt is made by Na and Cl bond together. And H2O is bonded with two H's and one O, but they're not bonded together here. Salt and water can be separated. But how do you separate it? Because if you just take it and run it through a filter, it's not going to really do it because it's dissolved. Salt is dissolved in water, so you got to do something else. So the physical property you would look at for this one would be the boiling point. All right? So you look at boiling the solution. Why would you do that? Well, you look at the physical properties and go, oh, salt has a higher boiling point than water. So if I boil it, the water will turn to a gas. The salt is still a solid at that temperature. And we'll talk about why salt becomes a solid and why water would boil off later on. But the idea is if you're boiling the solution, you'll be able to get water in another container if you really want to funnel it somewhere else. And you can have salt left over. You can simply let it evaporate as well. But either way, you're looking at just separating them through a physical property, okay? Now let's do a heterogeneous. Now remember, heterogeneous is when you have a solution and it's not equally distributed. So salt, if I take a little bit of salt water and put it in 2 cups, or like I have salt water, I mixed it up and I put it in 2 cups, it's going to have equal amounts of salt in each one if it has equal amounts of water. It's evenly distributed, but not when we're talking about heterogeneous. So let's do an example of, I don't know, let's do pebbles in water. So if I have pebbles, I'll just say rocks, okay? If I have rocks in water, okay, going back to the old video to keep it the same, I go, okay, how do I separate this? And you would be like, oh, well, you can just separate it by taking the rocks out, yeah. Or if you have smaller rocks or anything like that, you're going to look at something though. You want to look at the physical properties that's different than rocks and water. The physical property of Na and NaCl and H2O was the boiling point. Here we can look at the solubility. Rocks do not dissolve in water, okay? So if you look at the solubility, which is a physical property, you are able to separate that through just a simple, you can just use a funnel or just a screening, and you can actually just do it that way. So looking at solubility, you're able to separate the rocks in water by just using a screen, you know, or a filter. Screen, filter, whatever, but you're basically able to do that because rocks do not dissolve in water, so therefore you can get that out. So that's just another physical property you're able to do. So looking at physical properties for mixtures and then looking at energy or a chemical reaction to do compounds is how you're going to be able to separate everything. So look at this, make sure you're understanding this, because once you classify matter, the next thing is how do you separate it. So make sure that this makes a lot of sense for your future preps for the tests and labs and everything you have to do. Okay? Good luck.